So today we're going to look at internal trees, and especially with regards to data processing. Okay, so double click into the data manager, add a data set, add a build data set, and we'll make our waveform scan, and we'll just delete that for now. And we drag that out. So just to remind you, we have a 3D data set, so 3 axes of data, and we drag it on the basic view, and you can walk through the slices along the 3rd axis. So that's our starting point. We're going to right click on the blue, the data output here, and we're going to add a waveform scan analyzer, and I'm going to drop that right on the title bar here, and that will give us a split view. Got it organized a bit, and let's just get a sense of what we're looking at. So basically this tool has summarized the 2D data in sort of a better way than just giving you a slice, a single slice through the data. So these are all live, so you can see here that I've got the cross section again, or I'll do both of them, and you can see the cross sections in the 2 directions. And if you look at your axes up here and you look at the numbers, you can see that this is axis, this is axis 2, this is axis 3, and the one with the waveform is axis 1. Okay, so this is sort of looking at a view of axis 2 and 3, and then the slices are through them, and where the cursors cross, you're getting a single waveform. Okay, and yeah, you probably just sit with that and get your head around it so you understand what's going on. And then the main point of this video is, how is this done? So I'm going to split the manager, and I'm going to drag the waveform scan analyzer there, and you see an internal tree pops up. So just in general, whenever you see this icon here, there is a tree that lives inside this node. And this is what the tree, so you can either double click on the tree to open it up, or you can drag it out onto another manager view and see it that way. Okay, I'm just gonna talk about first of all the data flow, because I think that's the big concept, and then we'll look at a few more details. So I'm going to put another node on after the waveform scan analyzer, and I'll do cluster analysis 2D, drag that on to there, and drag that out. So this tool, the cluster analysis, has basically picked everything above a certain level. I'm guessing it's 50%, and so those are all the blobs that came in at above 50%, and it's marked them. So that's its job. But let's look at the flow of the data here. So we've got the data set. This node runs, and it spits out this output, and then the cluster analysis runs, and it tags the indications. But the thing we went over quickly was that the waveform scan analyzer ran, and what that did is it ran this internal tree. So in general, the pattern you need to know is an internal tree will run as the execution step of its container node, its parent node. So when this runs, it runs all this guts, and then it goes on to the next thing. So it lets you encapsulate some work inside the node here. And just to go into the specifics of what this one is doing, is this node here is the one that's in the top left, and it takes a single waveform, or A scan. It applies a gate to it, and then the peak in the gate is taken as the amplitude, and then this icon here, which is added or removed using this expose task, means stick me as an output on my container node, the thing that the internal tree is living on. Okay, so you can see that as I move the gate around here, I'm going to move this down. The cluster analysis is a little bit of trouble keeping up. But you can see that as I walk through the position on the first waveform, that those dots come and go, because if you look in here on this cross section, they're at different depths. So that's what that's about. And I was zooming in there. Okay, so how the execution of this tree goes is this waveform scan analyzer takes each original waveform from the source data, presents it to this tree, runs it, gets a result, and puts it in a pixel here. And it does a double loop through the whole thing, runs it all the time, or runs for every point, and collects the points on the output. I'll just show you that this is all configurable, and you can change it. I'm going to put a TOF node, that stands for time of flight, basically a fancy way of saying position, and I'm going to expose that, and you see I get another output here. So these are the times of the various peaks, and you can see that there's variation as they get deeper and shallower in the part. Okay, so this node here is an engine that runs through, presents a waveform or an image, in these cases the horizontal and vertical slices, runs it, and then captures data and puts it back. And just sort of practical uses, this can, when you're working with big data, if the root is, say several gigabytes or something, approaching the memory limit of your computer, that doing one at a time can save you memory. If I put each of the nodes right on the root, it may make a copy of the data, and your memory usage could add up. And also for more advanced use, if you're really big, say you're 100 gigabytes or 200 gigabytes, this node is smart enough to just say, I'm just going to pull things off disk and communicate with the node above it, and so you don't need to have all your memory and all your data in memory, and it'll just pass them through. Okay, so a little bit of details on what's happening on this node, but our main pattern we want to look at is the internal nodes, because those are used in a bunch of places. I put the cluster analysis on there. I'm going to drag it up to the amplitude, put it out, because it has its own internal tree. Now the cluster analysis has a table on here, and if I do, I think depth will get me one. Yeah, depth column. I can drag a depth column on here. I can run this node just to review the patterns. Shift or double click on the folder. I can see my depth column object there, and I've got a depth column here. I think there's nothing because I haven't set it up or it's the wrong data type, but you see the pattern. Another one worth knowing about is subtree, and it's sort of a generic node, and it just gives you an internal tree. And say I could I'm going to do amplitude on this. It's not going to be very interesting. And then run that and do my expose again, and it comes out there. I think that's going to be all flat because the peak amplitude's the same on all of them. That's what I expect. Okay, So the internal nodes occur in a bunch of places. Probably one that I'll just point out, but I won't go over because there's probably too much to cover, is label indications. In that case, the general pattern is it tags a bunch of regions, and then it sends each of those regions through the internal tree, and then you can capture properties of those regions. So, you know, if I run this, oh, this one is 3D, so it's gonna. You can see it's picking up some of those regions there, and it would put them through the internal tree. But I think that probably should be a whole other video. Anyway, just to review the pattern, when it's an internal tree, the execution runs the guts, gathers the outputs, and then the execution of the tree continues on.